The next model of our atom is called Rutherford's model of the atom. It was found or discovered by Ernest Rutherford. Before we talk about his model of the atom, let's review where we've come from so far. So we started with Dalton's model of the atom, which he created in 1807. And remember, his was just a solid sphere. There was nothing inside of it, it was just a solid sphere. And then Thomson came along in 1897, and he did his work with the cathode ray tube, and he discovered that there were negatively charged particles that he called electrons. And so in his model of the atom, the body of the atom is positively charged, and it has negative charged particles, electrons, randomly distributed throughout. There's not a lot of order to it. Rutherford did an experiment called the gold foil experiment. Basically, he shot alpha particles at gold foil and observed what happened to the alpha particles. If Thomson's model was correct, where the negatively charged electrons are randomly distributed in the atom, all of the alpha particles should have gone straight through. They knew that electrons were very small, so they shouldn't have occupied any space. The alpha particles should have been able to move straight through without hitting anything. What he observed, though, was that some of the particles went through, but some of the alpha particles would bounce back. That means something was in their way. They couldn't move through the atom. And when they hit whatever that was, the alpha particles bounced back. From this, Rutherford was able to conclude that an atom has a nucleus. It has this piece in the middle that's getting in the way of the alpha particles moving through the atom. So he modified the model. We now have a dense positive nucleus with the negative electrons orbiting around the nucleus. So we still have to have both our positive and our negative charges in order to make something neutral. So he said that the electrons were moving outside and the positive, the protons, were in the inside of the atom. That made up the nucleus. So we now have two subatomic particles. We have our electrons that we had from Thomson's model, and we have our protons. Those are the positively charged particles. So protons are positively charged particles. To complete the model, James Chadwick came along and he made some observations about different atoms. And he observed rays that would come out from the nucleus, and he noticed that they were neutral. They had no charge. They weren't positive or negative. So there were these neutral particles that had about the same mass as a proton, and he called those particles neutrons. So Chadwick discovered that there was something else in the nucleus besides the positive protons. He said that there were neutral particles called neutrons that were about the same mass as a proton. So our nucleus now has two pieces. It has the neutral neutrons, it has the positive protons, and that makes up that dense center of our atom, that makes up our nucleus. And then our electrons are still orbiting around the outside of the atom. So to summarize where we've come from, we started with Dalton in 1807, solid sphere. We moved to Thomson in 1897 with the electrons randomly distributed. We called that the plum pudding or the chocolate chip cookie model. And then Rutherford in 1911 discovered the positive nucleus, and then Chadwick added the last piece, the neutrons, in 1932. So this is where we're stopping for right now. We have a positive nucleus that has two pieces, neutral neutrons, positive protons, with the electrons around the outside. So we have three subatomic particles. We have our positive proton, our neutral neutron, and those are in the nucleus. And then we have our negative electrons, and those are outside of the nucleus.